Hey everyone, welcome back to the channel. So today we will see the three words that get thrown around constantly in networking and system design: latency, throughput, and bandwidth. They sound interchangeable. People use them as if they mean the same thing, and that confusion causes the real problem. By the end of this video, we will know exactly what each one means, how they differ, and which one we should actually care about for a given problem. So I will try to show the images and do some analogies. So let's see. So the core issue is when something feels slow, okay, a website or a game, a file transfer, we generally blame one thing and say we just need more bandwidth. But the term slow can come from three completely different places. And these places are bandwidth, throughput, and latency. Okay. So bandwidth is about capacity. Throughput is about how much you are actually delivering, and latency is about delay. Okay, so if you mix these all things together, we will spend money widening the pipe when your real problem is like the distance. Okay, and consider it like a wider pipe does nothing for that. Why? Because the problem was distance. So let's define each one clearly, and for that we will use a simple picture and a real life analogy with a water pipe. The easiest way to keep these straight is to picture a single water pipe. Okay, let's consider we have water pipe here, and three different things describe that pipe. Okay, first, how wide the pipe is. Okay, this part, how wide or width we can say the pipe is. The most water it could ever carry, okay, is the width of the pipe, which tells us how much water it can carry at most. Second, how much water is actually flowing through it. Consider this part. So we can say like the actual water which actually flowing through it, which might be less than the pipe could handle, right? And third, how long it takes a single drop to travel from one end, consider this end, to the other end of the pipe. So these three ideas we have: the size, the flow, and travel time. These three, size, flow, and travel time, these three actually maps to bandwidth, throughput, and latency. So for now, keep this picture in mind, and we will do all the we'll see all the details and try to put all the details along with this picture. So latency is basically the time for a single drop to travel from one end to another. So what we discussed, size basically maps to bandwidth, okay, flow maps to throughput, and travel time maps to latency. Let's start with bandwidth. Okay, the width of the pipe, as we discussed in the previous slide. So bandwidth is the maximum amount of data a connection could carry each second. Okay, the keyword is could. Okay, here the keyword is could. Basically, could here means its limit. So if we say theoretically, it's a ceiling. So it's a best case. The best case, okay, how much it could carry, not what it is actually carrying. Okay, so how this best case or theoretical ceiling is set? It is set by the link. By link means the fiber we are using or a copper or a Wi-Fi, okay, and the plan we are paying for it. So based on that, we get the limit like 300 Mbps, 100 Mbps. So we measure it in bits per second, Mbps or Gbps. Okay. So as we discussed in the previous slide, if we do some analogy with respect to pipe, width of the pipe, we can say its diameter is the bandwidth. So what generally people miss is more bandwidth gives you a wider pipe, but not necessarily a faster experience. So bandwidth is the capacity what could flow, but not what will always flow. Okay. So a wider pipe is not a faster one. Okay. If you take more bandwidth, it will raise your limit, but not the delay. Okay. So now see, bandwidth is what is possible. Okay. What we could do, but throughput is what actually happens. Okay. Throughput is the amount of data we actually move each second, okay, in the real world. It is always less than or equal to bandwidth. Okay, it will always be less than or equal to bandwidth because we cannot go more than the capacity. Okay, so protocol overhead, network congestion, packet loss, retransmission, they all consume our bandwidth. Okay, congestion, errors, they all consume bandwidth. This is usually the number we actually feel when we are transferring the data. Okay, even though we casually call it a speed, okay, in layman terms, in our real life we call it a speed, but this is what the speed we talk about is actually a throughput, what we actually get during the transfer. So if bandwidth is the pipe is the size of pipe, so if bandwidth is the size of the pipe, throughput is the water actually flowing through it. So we can say throughput is delivery, what does actually flow. Okay, so what happens is like during transmissions we are also drop some packet. Okay, it is basically sensitive to conditions. It is also measured in bits per second actual flow. Okay, it can be Mbps, Gbps, etc. Now the latency, this thing is completely different from other two were related, but latency is completely different from the other two. Latency is basically time it takes for data to travel from source to destination. So here, if you will see the unit of latency, it changed to milliseconds or microseconds. Okay, not the megabits or gigabits, GB or MB. So we can say latency is driven mostly by distance and the number of hops along the way. Okay, we will see all these things details in some other videos. So we often see it as a round trip time or RTT. Okay, and it is like going at some place and coming from there back. Okay, which is exactly what ping measures. If you have seen or used the command ping, this is what ping measures. Okay, it measures latency. So if we talk about in terms of our pipe, latency is the time it takes, okay, for one drop to cross the pipe from one end to other end. So we can say latency is basically delay. Okay, how long it takes to arrive. So this insight will ties all together latency, bandwidth, and throughput. High bandwidth doesn't mean low latency. Okay, these two are different. If we take an example of a satellite internet, it can carry plenty of data. Okay, so the bandwidth is fine. Okay, but every packet which needs to be transferred has to travel tens of thousands of kilometers up to the satellite and back. Okay, so it feels laggy no matter what we do. Or we can take another classic example, like consider we have a truck, right, full of trash driving across the country. The amount of data it can move is enormous data, right? So it has enormous bandwidth, but it will take hours to arrive, right? So it has a terrible latency. We can say it's awful. So capacity and delay are different problems, right? How much we can carry and how much time it is taking to carry that data. These two things are different. We will have to optimize the one according to our situation, and it actually depends on the situation only. Okay, so capacity and delay are different problems. Optimize the one according to our situation. So in this slide we will cover all three side by side and the differences between bandwidth, throughput and latency. Okay, so if I say in one word, bandwidth is capacity, throughput is delivery, and latency is delay. How these all three terms are measured, or basically what the unit is. So bandwidth and throughput both are measured in bits per second. Okay, second thing is what it measures. Bandwidth measures maximal possible data rate. Okay, throughput measures actual rate achieved, actually what data is flowing, and latency is time to travel. Okay, the unit for bandwidth and throughput for both of these would be bits per second, mbps, gbps for bandwidth, and similarly for mbps and gbps for throughput. And latency is, since it's a delay or time to travel, it is measured in milliseconds or microseconds. So if we compare it with the pipe analogy, it's a width, throughput is flow, and latency is travel time. So if we talk in terms of pipe analogy, bandwidth is width of time, throughput is water actually flowing, and latency is time for a drop to cross from one end to another. When do we notice the bandwidth or throughput? We notice low throughput when we try to transfer big data. Okay, when we notice high latency, when like clicks or any action feels laggy, right? And when we basically notice with bandwidth, we notice it when we try to do speed test, right? And there we see low speed, and we fix them differently. Okay, more bandwidth or less overhead for the first two we need, right? Upgrade, we have to upgrade the link or a plan for the more bandwidth. And for latency, we need to shorten the distance and the hops from sender to receiver or receiver to sender. So when to choose what to optimize? So it totally depends on what we are doing. We have to choose latency when the walk is small and interactive, like online gaming, video and voice calls, right? Because every millisecond of lag we can see in video also. Even if there is a millisecond of lag, we will see the lag in the video. Similarly in the voice calls, where a delay makes people like talk each other, right? APIs and web-based apps we have, right? We need snappy clicks there. We need low round trips. Okay, or when we are doing high frequency trading. In high frequency trading, where microseconds are literally money, within microseconds we can lose the money. Okay, we have to choose throughput and bandwidth when we are moving large amounts of data, like large downloads or uploads, like or 4K video streaming, backups and migrations, or we have big data pipelines. Okay, so I will give you a quick rule of thumb for when to choose between latency, throughput and bandwidth. If it is a small and interactive, we will have to fight latency. If it is big and bulk, we would have to fight throughput. Since these three terms interact with each other, latency can actually throttle the throughput. Okay, when we use a protocol like TCP, the sender possesses a chunk of data, a window. We call that chunk of data a window. Consider it as 1 MB. Okay, and then the sender has to wait for acknowledgement. Okay, whenever sender sends a data on TCP, it pushes a chunk of data, then waits for an acknowledgement before sending more. Okay, so the farther away the other side is, or we can say farther away the other side is, or the receiver, the longer it will have to wait for the acknowledgement, like so the less it will push per second, right? Because it will wait first for the acknowledgement, then only it will send. So it can push less, it will push per second, even if we have a huge link, right? So we can say roughly the formula for throughput would be window size divided by RTT. RTT is round trip time. Round trip time. Time to reach the destination and get the acknowledgement from destination to sender. Okay. Source, destination, and from destination to source. Okay. So total turnaround time or round trip time. So if we take an example, if we have 1 MB of data, right, or window size, and our RTT round trip time is 100 milliseconds, and we divide it, okay, so we can get a throughput, and it would be, so consider it is 1 MB, consider this RTT as 100 millisecond, and we divide it, we will get 10 MB per second. So even if you have a bandwidth of 100 MB per second network link, like a single TCP connection here will only achieve about 10 MB per second. Why? Because it is constantly waiting for the full round trip for the acknowledgement. Okay. Now, if we talk about data in flight, okay, or bandwidth delay, okay, so we can say what is data in flight? Data in flight is bandwidth delay with the product of RTT, round trip time. So if we have a 10 GB link to a server, okay, and we can say it's a 150 milliseconds away, right, will mostly sit idle. Why? On a single connection. So that's why what we do, we move servers closer to user CDNs or edge location, or we do regional replicas instead of just buying more bandwidth. Okay, so in flight we can say like a long flat pipe needs a big window, right, to just to stay full. So we can say adding more bandwidth is like buying a bigger truck. Okay, but reducing latency is like moving the warehouse closer. If the warehouse is very far away, even a huge truck like spends most of its time traveling instead of delivering the data. Okay, so if we have a 10 GB gbps link to a server and it is 150 milliseconds away, okay, so we can calculate in this way how much time and how much its actual throughput would be. It will mostly sit idle on a single connection. Okay, that's why we need to move servers closer, or put our data to CDNs, or make regional replicas, okay, instead of just getting a bandwidth. So now let's lock in what these all three terms were in weekend. So bandwidth is how much data could flow, we can say the size of the pipe, and it is measured in Mbps or Gbps. Throughput is how much actually does the data flow, okay, the real delivered rate. And also its unit would be Mbps or Gbps. Latency is how long it takes to get there, okay, and we call it a delay, and it is measured in milliseconds. So we have one line to remember is bandwidth is the size, throughput is the flow, latency is the weight. Yep. So with this we are done with this lecture. Hope you would have liked the lecture. If you have any doubt, please comment. See you soon.